Let's do sound class basics with me. This is instructional video number 17, broad concepts. Today we're going to do a video about the broad concept of time and, more importantly, time alignment. Let's just do it like this. The easy rule, this simplified rule, will be like this. If sound signals, plural, are in time or aligned in time, they will increase in amplitude. If sound signals are not in time, if they're out of time or if they're not time aligned, they will change the signal and usually decrease the amplitude because of the changing of the waveforms. Again, I'm trying to stay simple on this stuff, so I want to make it as perfectly simple as you can. Let's do a visualization. And let's talk about what a sound wave does. And what a sound wave does is it creates a disturbance in the air molecules by using compression and rarefaction. And compression is when you smash molecules together, and rarefaction is where you pull them apart. If you can look at any field of space, there's molecules in there, and if I push an object closer, it will push all of those molecules to bounce off each other. That will compress the molecules, and as I move that object back in space, it creates a rarefaction where it opens that up and it spreads those molecules out. Now, that happens many times in a second, and that vibration is what causes sound. So we know that from another video. But in this purpose, when we talk about time, I want you to do an experiment, and what we're going to do is I want you to take both hands. I hope you have both hands. If not, you can find a friend that has another hand. And you're going to put your two hands in front of you like this. And you're going to imagine that one of the hands is going to push towards you. And when it pushes towards you, it's compressing all of those molecules together. Now, understand that when you do this, all of those molecules have to bounce into each other, and they have to push each other together, and they also have to have somewhere to go. And if you look at my hand, once I push this forward, it's going to push the molecules together towards me to create a wave that starts moving in this direction. But at the same time, it's also going out to the sides because it has to push the molecules that once were in this space. So this other hand is going to come into play here in a second. So here we have one sound signal, and I'm pushing with a compression. And some of that is going to spill over to the side. It's in a three-dimensional space. We can get into that later. But what I want to try to do here is to add a second sound source or signal. And now we're going to do both hands, and we're going to push them both together like this. And what you'll find is twice the amount of compression, and therefore twice the amount of amplitude. Now, as we move along, we can do something to experiment the exact opposite. And what I want to do is to pull this hand back while I'm pulling this hand forward. And I want you to visualize again what happens to the molecules that we're displacing. If I move in this direction, what's happening? I'm rarefacting the molecules over here, and I'm compressing the molecules over here, which means that there's going to create such a disturbance that these molecules and these molecules will figure out a way to equal out. Once that equal out happens, you don't have a sound wave anymore, and therefore you're getting no sound. Now, this is a very simplistic way to look at it, but it's a way that you can visualize how this timing works. This concept, and as we go twice as much sound, no sound, there's also all of the in-betweens. And the important thing to remember is if I have a speaker that's here, and I have a speaker that's here, and they're both outputting a sound signal at the same time, then those two signals are going to reach me at different times and are going to affect that acoustic energy that I'm hearing. And so what I want to try to do in my sound systems, in my multiple speaker sound systems, is to time align them so that this speaker doesn't begin until this speaker's signal can reach here in time. So if this is a particular amount of time away, let's say 10 milliseconds away, I'm going to start this speaker, and 10 milliseconds later, I'm going to start this speaker, and guess what? They're both going to hit me at the same time. Okay, I'm going to move on with this video. We're going to be done with that. I just want you to know that that is why time is your friend. That is why time can be your enemy. And I also want you to remember that when we talk about this stuff, I don't really so much want to talk about the good and bad. It's not a good and bad thing in design, and it's all about desired and undesired outcomes. As you move through this process and you start to want to manipulate stuff in a way that serves your purpose, that's the important part. Is it desired or is it not desired? Thanks for watching. Take care.